Okay, so the third type of getting a charge through static is what we call induction, and we're going to use our little friend called an electroscope here to help us out. And all we have to do is track where the electrons go. So the first situation is here's an electroscope. All we have is a charged rod here. You notice that it's all positive, so it has a positive charge. And then the electroscope, we have what's called a pith at the top here. It's just like a little ball, something like tinfoil or something. And then I think the one we make in the lab, we use like a old piece of coat hanger that we've cut, and or copper wire actually. I think the ones that we built were copper, and then little pieces of tinfoil, just little tiny strips of tinfoil that we hang down. And what we're going to do is we're going to take this positive rod, and we start with one charged object, which is the rod, and one neutral object. See this little electroscope? It has two neutrons and protons up here. Sorry, two protons and electrons up here. And it has just like a pair of protons and electrons. Now, in reality, it would have like quadrillions of these, right? Way more, but we're just trying to make it simple here.
Think back to that big number that we looked at.
Yeah, 6.25 times 10 to the 18. Or 62.5 quadrillion electrons per column, and there's like millions of columns here. Okay, so when we move it close to it, notice we don't touch it. And if we touched it, that'd be charging through contact. We don't want that. We don't want to touch it because then it would just be contact, right? We just move it close. And if we look back to the laws of electrical charges, we know that opposite charges attract. So if this is positive, it's going to attract all the negatives. Now, these electrons are already pretty close to it, so they're good and happy. But what about these electrons? Are they able to move? Well, absolutely. And we find that that's actually what happens. They move up. Now, the electrons move. So we also know that the same charges are repelled. So the positive here and the positive here, they repel each other. But why is it that they don't move? Well, they can't, because these protons are kind of stuck in place. So the electrons move up, and now on this object we have an area where there is a negative charge. Okay, we have more electrons and protons up here. But here we have two positive regions. Now, these leaves, notice how they're not attached at the bottom, and they're both positive. What are they going to do? They're going to want to, just like your hair, right? That's why your hair stands up and pushes apart. They're going to want to
move away from each other.
They're going to want to move away. And that's what happens. They repel. When the electrons shoot up, right, they're going to want to move away, and they repel. And that's what induction is. I've used a charge to create different regions of charges on an object. Now, the logical question you should be asking yourself is, well, sir and miss, this works with a positively charged object. What would it look like if I used a negatively charged object? Well, good news. We did that one too. Here you go. Same thing, negative charged object. We're going to bring it nice and close. Now let's think about it logically. What happens? This is negative, so all the protons are going to be attracted to it, but the protons can't move, so we'll just ignore the protons. They don't exist. We don't care. The electrons, though, here, this is negative, so these electrons are going to be repelled, but they're able to move. So what are they going to do? Well, they're going to escape down the electroscope to the leaves, and that's exactly what happens. Now I have this leaf and this leaf, which are both negatively charged. What are they going to do?
Move away from each other.
Yeah, they're going to repel. There you go. And they repel. Okay. So we have one charged object and one neutral object, and that still stays the same at the end. Like, this electroscope is still neutral. It just has areas that's charged, positively charged, and areas that are negatively charged.
So we can go backwards and move the electroscope away.
Yeah. Exactly.
And the electrons would travel back.
And it's kind of cool when you do that, right? Yeah, because this is positively charged, this is negatively charged, right? So if I get rid of this rod, well, these electrons are now going to want to come back up and balance out. And they actually go back to this rest state. So it's really cool with this because I can move the charged object near it and away from it, near it and away from it, near it and away from it. And it actually causes the electrons to cycle. And if I do this with some really cool gearing, you can actually create like an induction motor or an induction burner. And a lot of engines and motors and stuff like that actually run off of induction. It's a very, very important process. But the most important part is that we're not actually touching them. There's no contact here. Okay, so induction. Very similar. You know, you can create electrical fields from this, and then again, we can use electrical fields to use for motors as well. So there's a lot of really cool engineering applications here. But there you go. Those are the 3 different kinds of static creating charges through static electricity. And the way we would charge this object, well, we can charge it by contact. We could create the charge on this by contact. We can create it by friction. So at its basis, we always get these things. But you can actually create charges through induction as well. So just keep that in mind. But anyway, there it is. And if you have any questions, feel free to reach out and talk to us. If you want more information on it, we're not going to really go into depth more in class about it. I would highly encourage you to, you know, watch them build I or stuff like that. There's a lot of really cool little videos on YouTube. You can just type in like what's static electricity, maybe check out how lightning works. A lot of cool activities. Get a balloon in your house and experiment trying to like rub it on your hair and stick it to things, or pushing pop cans around with a charged balloon. But lots of cool little things you can do. But that's about as much in depth we're going to get to here. Okay, well, hopefully you enjoyed this video, and stay tuned for the next one talking about current electricity.